Hey everyone, welcome to my channel, where we dive into the most mind-bending mysteries of science and the universe. Today we're tackling a topic that has fascinated philosophers, physicists, and dreamers for centuries. Do parallel worlds exist? Imagine infinite versions of yourself, living out every possible choice in separate realities. Some where you chose a different career, won the lottery, or even where historical events unfolded in wildly alternate ways. Is this the stuff of science fiction, like in movies such as The Matrix or Everything Everywhere All at Once? Or could it be grounded in real scientific theory? In this video, we'll explore the concepts in depth, from their philosophical roots to cutting-edge physics, examining theories from pioneers like Hugh Everett and Alan Guth, and weighing the evidence, criticisms, and mind-blowing implications. We'll see why many experts believe we're part of a vast multiverse and what that means for our daily lives. Buckle up. This journey through quantum weirdness, cosmic inflation, and the frontiers of consciousness might forever change how you see your own reality. Let's get started. The idea of parallel worlds has deep historical roots, weaving through mythology, philosophy, and early scientific speculation, long before modern physics gave it a rigorous framework. In ancient Hindu texts like the Vedas and Upanishads, dating back to 1500 to 500 BCE, the universe is described as comprising multiple lokas, or realms, parallel planes of existence where beings live in varying states of enlightenment or illusion. These aren't just metaphorical, they suggest layered realities influenced by karma and consciousness. Similarly, in Greek mythology, the concept of alternate fates appears in stories like the fates weaving different threads of destiny. Philosopher Democritus, around 460 to 370 BCE, proposed an atomic theory where infinite atoms in the void could form countless worlds, each with its own laws and inhabitants, a precursor to multiverse ideas. Plato's allegory of the cave in the Republic, around 380 BCE, paints our world as shadows on a wall, mere projections of a higher, truer reality, implying unseen parallel dimensions. Aristotle, Plato's student, explored potentiality versus actuality, hinting at unrealized possibilities that could branch into other worlds. In the Middle Ages, Islamic scholar Ibn Sina, Avicenna, 980 to 1037 CE, discussed multiple universes in his metaphysics. While in the Renaissance, Giordano Bruno boldly claimed an infinite cosmos with innumerable worlds in his 1584 work on the infinite universe and worlds. Bruno's vision was so revolutionary and threatening to the Church's geocentric view that it contributed to his trial and execution in 1600. These early thinkers laid the groundwork, blending intuition with logic for what science would later formalize. Fast forward to the 19th century, when Charles Darwin's Evolution, 1859, and James Clerk Maxwell's Electromagnetism, 1860s, hinted at a deterministic universe. But quantum mechanics in the early 20th century shattered that certainty, opening doors to multiplicity. Quantum mechanics, the theory governing the subatomic world, provides one of the most compelling arguments for parallel worlds. Developed in the 1920s by pioneers like Max Planck, Albert Einstein, Niels Bohr, and Werner Heisenberg, it revealed a realm of probabilities and uncertainties. At its core is the wave function, described by Schrödinger's equation, 1926, which portrays particles not as definite points, but as probability waves, existing in superposition, meaning multiple states simultaneously until measured. The infamous measurement problem arises here. Why does measurement cause the wave function to collapse into a single outcome? This puzzled physicists, leading to debates about the role of the observer. Bohr's Copenhagen interpretation, 1927, suggested collapse is real but didn't explain why. Einstein famously disliked it, calling quantum mechanics incomplete and entanglement spooky action at a distance. Enter Hugh Everett III, a young physicist at Princeton. In his 1957 PhD thesis, Everett proposed the many worlds interpretation, MWI, a radical solution. No collapse occurs. Instead, the universe splits or branches into parallel copies for every possible quantum outcome. For example, If an electron can spin up or down, both happen, but in separate universes. You, the observer, also branch. One version sees up, the other down. Everett's math elegantly resolved the measurement problem without special rules for observers. The wave function simply evolves deterministically, encompassing all possibilities in a vast multiverse tree. Initially dismissed, Everett left physics for defense work due to ridicule. MWI gained traction in the 1970s thanks to Bryce DeWitt, who coined many worlds, and David Deutsch in the 1980s, who linked it to quantum computing. Deutsch argued MWI explains quantum interference. In the double-slit experiment, where particles create wave patterns, shadow particles from parallel worlds interfere with ours. In 1997, Deutsch's quantum Turing machine concept paved the way for real quantum computers, which in 2025, like IBM's Eagle with 127 qubits, simulate multiverse-like branching for optimization problems. Evidence for MWI is indirect but growing. The Wigner's friend thought experiment, Eugene Wigner, 1961, extended in 2019 by Daniela Frauchiger and Renato Renner, showed logical paradoxes in single-universe models resolved by many worlds. In 2022, a team at Oxford used photonic chips to simulate branching, supporting MWI's predictions for quantum correlations. Sean Carroll, in his 2019 book, Something Deeply Hidden, calls MWI the leanest theory, avoiding hidden variables or consciousness-induced collapse. Critics like Sabine Hossenfelder, 2022 Existential Physics, argue it's untestable. How do we detect other branches? But proponents point to quantum decoherence, Wojciech Zurek, 1981, where environments select outcomes, mimicking collapse without it. If MWI holds, every quantum event, every radioactive decay or neural firing, spawns new universes. With 10 to the 80 particles in our universe interacting constantly, the multiverse branches exponentially. This is thrilling. Infinite U's explore every path. But terrifying. In some worlds, disasters unfold. Nuclear wars, pandemics worse than COVID. Are we the lucky branch, or does every horror exist somewhere? Parallel worlds also emerge from cosmology, the study of the universe's large-scale structure and origins. The Big Bang Theory, proposed by Georges Lemaitre in 1927 and bolstered by Edwin Hubble's 1929 expansion observations, explains our universe's birth from a hot, dense state 13.8 billion years ago. But the theory had puzzles. Why is the universe so flat and uniform? Alan Guth's 1980 inflationary theory solved this, positing a brief exponential expansion, 10 to the negative 32nd seconds, that stretched quantum fluctuations into the cosmic microwave background, CMB we see today. Discovered by Penzias and Wilson in 1965, Nobel 1978. Guth's inflation was new, but Andre Lin's 1983 chaotic eternal inflation took it further. Inflation doesn't stop everywhere. In some regions, it ends, forming bubble universes like ours. Elsewhere, it continues eternally, spawning infinite bubbles. Each bubble has its own physical constants. Gravity strength, particle masses, tuned by quantum fields during inflation. Our bubble's constants are fine-tuned for life, anthropic principle, Robert Dicke, 1961. But in the multiverse, most are barren. We observe this one because it allows observers. Evidence mounts, CMB data from WMAP, 2001 to 2010, and Planck's satellite, 2009 to 2013, show temperature fluctuations matching inflationary predictions. Planck's 2018 final maps revealed cold spots and asymmetries, possibly imprints from bubble collisions. Laura Mersini Houghton, 2008. In 2023, James Webb Space Telescope, JWST images of early galaxies, formed just 300 million years after the Big Bang, appeared too mature, suggesting varying physics in distant bubbles or multiverse effects. Paul Steinhardt's 2019 cyclic model critiques eternal inflation as untestable, but Linda counters with potential gravitational wave signatures detectable by LISA, planned 2035 launch. String theory, aiming to unify quantum mechanics and gravity since the 1970s, Gabriele Veneziano, Leonard Susskind, supports a multiverse. In the 1990s, Edward Witten's M-theory unified 5-string theories into an 11-dimensional framework, where our universe is a brain membrane in higher bulk space. Vibrating strings determine particles and forces, predicting 10 to the power of 500 possible vacua, or universes with different laws. Joseph Polchinski's 1995 D-Brains and Raphael Busso's 2000 Landscape formalized this string multiverse, explaining fine-tuning. We're in a life-friendly vacuum among many. This cosmological multiverse is vast and impersonal. Infinite bubbles mean every possible configuration exists. Universes with reverse time, extra dimensions, or alien physics. It's awe-inspiring but daunting. Our existence is a statistical accident in an endless foam of realities. Beyond physics, biology and consciousness offer intriguing multiverse angles. Neuroscientist Giulio Tononi's Integrated Information Theory, IIT 2004, quantifies consciousness, PHI, suggesting it emerges from integrated systems like brains. If consciousness influences quantum measurement, as in some MWI variants, each observation branches realities, creating parallel conscious experiences. Robert Lanza's Biocentrism, 2009, flips the script. Consciousness creates the universe. Drawing on quantum observation, Lanza argues space-time are perceptual tools. His stem cell work, 2001, shows life's role in adaptation, and he posits a biocentric multiverse where consciousness explores infinite paths. In 2025, Lanza's neural simulations suggest microtubules from ORCA-OR tune into quantum fields, allowing consciousness to branch multiversally. Evidence is anecdotal but compelling. Near-death experiences, NDEs, studied by Sam Parnia, Aware Study 2014, report out-of-body visions and life reviews, possibly quantum glimpses of parallels. Psychedelic research, Imperial College London, 2022, with DMT induces breakthrough experiences of alternate realms, aligning with multiverse navigation. Critics like Victor Stenger, 2007, God the Failed Hypothesis, dismiss multiverses as unprovable metaphysics, lacking Popperian falsifiability. Yet future tests, like BICEP3's CMB polarization, ongoing for inflation signatures, or quantum simulators modeling branches, could provide clues. If parallel worlds exist, implications are profound. Moral choices matter across branches. Max Tegmark's Level 3 Multiverse. Time travel via wormholes to parallels? Infinite resources in a multiverse economy? But it's scary. Endless suffering in bad branches, diluted uniqueness. As David Deutsch says in The Fabric of Reality, 1997, embracing the multiverse empowers us to navigate probabilities. Thanks, friends, for joining this cosmic adventure. If it sparked your curiosity, like, subscribe, and comment. Do you believe in parallel worlds? See you next time. Keep questioning reality.